Production processes. There's a lot of them. I'm going to touch on several of them that really bring themselves to the forefront. We talk about productions and changes over here. Computer-aided design and manufacturing, flexible manufacturing. We're going to have something change almost instantly. Assembly line, make this product one or two or three pieces of this specialized style and back. Mass customization, robotics, 3D printing, a new term that we call it additive manufacturing, just in time, good and bad, lean manufacturing, and the Internet of Things. There's multiple other things coming online, but they're not really reaching the level of high level of interaction on production processes yet at this time. CAD/CAM, we've always equated it with developing engineers where they're working on a huge program over there to develop automotives. But nowadays, we're actually using it now for even something as basic as creating clothing prototypes, sitting out doing cuts and designs right on the computer before any fabric is cut whatsoever. So you're seeing a whole extensive series of CAD and CAM by the time you're done. In theory, what's supposed to be coming out in this, if you took it to the year 2050, we'll be able to stand in front of a mirror and just touch a button or click a remote control or just speak a command, and all of a sudden our clothing will change from this shirt to a different shirt to different shirt, different shirt. You can choose what you want to just by having the computer go through and show different clothing on you as you go through. We also have machines that are flexible manufacturing. Alan Brady, they use manufacturing flexible to build motor starters so they can sit down there and pre-program the system at the beginning of a shift, and you can crank out a variety of different kinds of motor starters, all that with almost no human interaction other than the initial programming as you go through. And flexible manufacturing allows you to be creative by having different models, different kinds of glass. Let's say you're having a glass, you have 75 pieces of clear glass going down the conveyor belt, and then you have 4 or 5 pieces of red, a couple pieces of blue, a couple pieces of green. Then you decide to toss different shapes as you go through. The machines can sit down there and pivot and change with the product they're producing to custom make the product to suit the needs of the customer that you're selling to. Mass customization. As you go through now, you can order a pair of tennis shoes, custom made just for you. And that comes from the sole, comes from the sides, the thickness of the sole, the thickness of the sides, the color of the leather on the top, or maybe it's canvas. You could also have the way that the laces are designed, the color of the laces, the size of the tongue, the thickness of it as you go through. You can do a massive change as you go through and have mass customization, and you place your order in and you get your order back 2 weeks later, and it's exactly what you want. The logos in the spot that you dictated, they're the color that you dictated in the sole. It's exactly what you want. And it may cost a little bit more, but those pricing are even coming down further and further. And there's very few humans involved with the customization as we're pivoting with the machinery that's going to sit down there and tailor the products to meet your individual needs. Robotics. Once upon a time, we view them as nothing more than humanoid-shaped critters, except for the fact now they're very specialized devices that sit down there and they assemble things at a much faster rate with a consistent high quality as you go down an assembly line. They can do all kinds of huge grab, pickup, pivots as you go through that a human could not even conceivably move by themselves. So that being said, you save a lot of workers' compensation problems. You also save a lot of technology problems, and also the aspect of what are the humans doing? The humans are watching over the robots. Let a robot get off just a little bit, though, you may have a major quality problem. Got to shut it down and make sure it's right back online. But they can actually work 7 days a week and 24 hours a day. And you know what? They don't even want a bologna sandwich in the middle of the day or have a coffee break. Go ahead, give me a good old can of oil and everything else about once every week, and I'm happy. That's what they say. And there's no union contracts to worry about. They don't even sit there and ever file a grievance, and they don't complain to management saying, hey, it's hot in this factory. Can you turn down the temperature? They don't do stuff like that because they're robots, and they do it selflessly because of their love for the company. Huh? Okay. Yes. 3D printing. We call it additive manufacturing. We create one layer at a time, and it goes anywhere from cheesy plastic toys and parts that people make in the garage on a $300 machine, and all of a sudden now you go to a $30,000 machine and you can start doing all kinds of things, including having it go through and take a pig's heart, reduce all the extra flesh off of it so you have just the structural materials, the organic materials, and then you put on human cells on top of it and make it ready for a human to receive it, sometimes with their own different tissue that's grown on top of that original pig's heart in the process. They do all kinds of things. You can make a cake from a 3D printer in the process, to the point that you can also have one inside of an airplane hangar in case one unique part breaks down. They can actually go through and they can formulate the part, the replacement part, on a 3D printer and get that plane back up in the air in a couple hours rather than waiting 3 weeks, rather waiting for a part to be manufactured at a manufacturing point. Printers available for less than $200, going up to thousands and tens of thousands of dollars that can do all kinds of things, from cutting steel to cutting cake as you go through. Some of the incredible parts, things that are coming as we go through. Just-in-time inventory, one of the biggest banes that we had during COVID. Oh my gosh, the purpose of just-in-time, it really started from Toyota, okay, in Japan. Now, by the way, they call it Toyota instead of T-O-Y-O-D-A, okay, rather than Toyota that we have in the United States. Toyota, they first came out with just-in-time inventory. They had a factory they built, and right next door to the factory was a supplier, and a supplier, and a supplier. They surrounded the Toyota factory with additional suppliers around them. So literally, a worker would reach down into a bin and grab a shock absorber. There'd be 4 of them. And literally what's supposed to happen by the time it's done, the worker puts that on. By the time they get to the 4th shock absorber, a pallet is coming across from the supplier next door. The supplier high-low comes into the entryway. All of a sudden, it's scanned, and another bin of shock absorbers is picked up and paid for right then on the spot. And the high-low keeps on driving in, and the worker sits down, reaches in, takes the last shock absorber, and that bin plops next to it. The high-low picks up the empty one and heads back next door. And literally, the part shows up just in time. Gee, I think that's where they got the name from. Just in time. It saves massive inventory costs in the whole process, and it saves a lot of money where Toyota then can use its own money to sit down there and invest in capital rather than investing in excess inventory. It sounded great. It worked great for decades, and then COVID hit. All of a sudden, we walked into the stores. There's 24 feet of empty grocery shelving. People panicked. They were terrified to death in the process. All of a sudden, that was because just in time doesn't work when a truck driver gets sick and can't come into work, and they miss the schedule. They miss that. We had the famous toilet paper crisis. There was plenty of toilet paper, but the market got wiped out, so to speak, because of the fact they couldn't get it in time to the actual final destination for people to pick up. So just in time actually went just out the window. We'll see how fast it comes back. Now Toyota, its goal is to have a 4-month inventory of all supplies as we go through having different parts of our economy with spatterings of outages because of the fact that just in time sat there, didn't work in time. We'll see what happens with this in years to come. Lean manufacturing. I was amazed on all things when I first saw this. I'm teaching this class, talking about lean manufacturing, and I saw a garbage can. What does a garbage can got to do with it? It's got everything to do with it. I had a crack in my garbage can, the ones where the machines come by and they pick it up at your curb and they dump it and they put it back down. So I got a brand new one, except this one weighed, instead of weighing about 40 pounds, it only weighs about 15 pounds. And the sides, they're not flat and they're not super heavy. They're kind of thin and they have little almost bubbles on the outside of them, but you can tell that it's super strong in the process. Super strong, super light, highly engineered. Then all of a sudden they use less than half of the material to make the can, yet the can, I would bet if you sat there, went through a stress test, is probably functionally stronger than the previous one because of the design and the shapes that they put in on it to make certain it's strong and heavy duty. It takes up less space. It also takes up less materials and saves the manufacturer money in the process by using lean manufacturing. So it's a production of goods using less of, well, everything in the process as you go through. The Internet of Things is going to allow electronic devices to talk to each other. Yes, it's true. The Terminator is true. The machines are going to be talking, except they're going to say, yo, you got any more shoelaces down there? I'm running low on shoelaces. Okay, I'll bring some over. Hopefully, we'll just talk about that instead of talking about zapping the humans with laser guns. But the machines will be able to talk to each other, especially once we get a solid 5G network across the entire United States. The Internet of Things is going to sit down and have machines talking to each other without humans having to relay the conversation or even push a button. Automatic will see the world's going to change totally with what we do. So production processes, there's at least 8 that you should know about because they're going to affect your lives. Computer-aided design and manufacturing, flexible manufacturing, mass communication, robotics, additive manufacturing, just-in-time, lean manufacturing, and the Internet of Things. Take care.